Now what we just finished was the first step here, and that was the summation of the forces. The summation of the forces had to be equal to 0, or in this case, force A plus force B came out to be equal to 400 newtons. But we still don't know what A and B are equal to, so now we need to use a second step, and the second step was to use the torques. So this sigma, it's a letter capital sigma, this means it's a sum. The sum of the torques, SIGMA of the torques, had to be equal to 0. Well, to solve this problem, it's usually convenient to pick one point as the rotation point. Now, in the case of mom and the child, the convenient point was in the very center of the seesaw. Well, in this particular case, a good point to select would be one of the endpoints. Let's select maybe this point right here where f sub a is equal to 0. So that's our rotation point. All right? Now, remembering what we said earlier about the torque, this force right here, around that point right there, would cause a rotation which would be going clockwise, CW. And this torque right here, well, that would also be clockwise. And this torque right here would also be equal to clockwise. Now this force out here, F sub B, that's going to be counterclockwise. So you have 3 in the clockwise direction and 1 in the counterclockwise direction. Now F sub A is actually at the rotation point. So that would be F sub A times 0. There's no torque produced by that force. So let me just solve this problem now. This is going to be the clockwise minus the counterclockwise, clockwise, counterclockwise are equal to 0. So let's see what we can do. F sub A is here. This distance is 30 centimeters. Times 0.98 newtons. Plus 50 centimeters times 1.05 newtons. Plus 80 centimeters times 1.96 newtons. 80 centimeters times 1.96 newtons. That's clockwise, but the counterclockwise is going to be F sub B times this entire distance, which was 100 centimeters. So it's going to be 100 centimeters times F sub B. And that's going to be equal to 0. Now, to make it easier, instead of using 30 centimeters, we could use 0.3 meters. So I'm going to use 0.3 meters times 0.98 newtons. And that comes out to be about 0.294 meters newtons. And this is 0.5 meters times 1.05 newtons. And that's going to be about 0.52 meters newtons. And finally, this will be 0.8 newtons, meters times 1.96 newtons. And that comes out to be about 1.56 meters newtons. Minus 1.0 meters now times F sub B equals 0. So now what we do is we get out our calculator. 0.52 plus 1.56 is about 2.08. 2.08 plus 0.294 would be about 2.39. 2.38. sub B is equal to 0. So we take this to the other side, subtract 2.38 from both sides. So now we have a minus 1.0 meters times F sub B will be equal to a minus 2.38 meters newtons. Divide both sides by 1.0 meters. By minus 1.0 meters. This would cancel with this. The meters would cancel out. And F sub B would be about 2.38 newtons. Now once we have the value of F sub B using this method, just using the torque clockwise and counterclockwise, once you know that, then we go back to the first part where we dealt with the forces. So here we have F sub A plus 2.38 is equal to 4.0 newtons. So that means this is going to be about 1.62 newtons would be F sub A. And that's the end of our experiment.